complexus tendency of alkaline earth metals. Complexus tendency of alkaline earth metals. Alkaline earth metals generally do not form complexes. Alkaline earth metals generally do not form complexes. The ability to form complexes is favored by small size of atoms or cations, high charge on cation, and availability of empty d orbitals. These are divalent ions and are smaller than alkali metals. Hence, alkali earth metals possesses better complexation tendency than alkali metals. Complexation tendency than alkali metals. Beryllium is smallest. Hence, it forms too many complexes. Magnesium, calcium have also some tendency to form complexes, and in ground state, beryllium has no unpaired electron, hence it does not form any covalent bond. In excited state, it has two unpaired electrons, which form two covalent bonds with F atoms. So beryllium forms a beryllium fluoride molecule, which involve sp hybridization having linear structure. Arsenic beryllium fluoride molecule has two vacant p orbitals, and beryllium is very small in size. Thus, beryllium fluoride readily coordinate with fluorine negative ions, forming BeF4 2 negative complexes, and as given below, you can show one S, 2S, 2S, 2p empty. No unpaired electrons, so no covalent bonds. No unpaired electrons show no covalent bonds. Okay, no covalent bonds. This is the electronic structure of beryllium atom. Electronic structure of a beryllium atom. Ground state. Electronic structure of beryllium atom, excited state. Electronic structure of beryllium atom, excited state. Okay, that is 2 electron and 1 electron, 2s, 2p, that is 1 electron. Okay, two unpaired electrons can form two covalent bonds. Okay. Electronic structure of beryllium in gaseous. Electronic structure of beryllium in gaseous beryllium fluoride, that is 1s, 2s, 2p. Okay, this is sp hybridization. hybridization. Sp hybridization. Okay. This is linear BeF2 molecule. Okay. Next is electronic structure of beryllium in electronic structure of beryllium in BeF4 2 negative. That is one S, 2S, 2P. That is sp3 hybridization tetrahedral. sp3 hybridization sp3 hybridization tetrahedral. Okay. This is two fluorine negative ions, each donate an electron pair into an empty orbital forming a coordinate band. Okay. Then arsenic BeF4 2 negative involves sp3 hybridization. Hence it has tetrahedral structure. Tetrahedral structure. Okay. Beryllium also forms a complex compound with oxalic acid. Beryllium also forms a complex compound with oxalic acid. The structure of beryllium oxalate ion complex. Okay. This is tetrafluoroberylate complex. Tetrafluoroberylate complex ion. And this is beryllium oxalate ion complex. This is a cataborylate. This is a catocobariate second ion. And this is a BIS. BIS means ethylene-diamine beryllium second ion. Ethylene-diamine-beryllium second ions. And this is salicylato-berylate second ions. Okay. Second ion. In addition to this, beryllium also form Catechoberylate second ion, salicetoberylate second ions, bis-berylate second ions, basic beryllium acetate, basic beryllium acetate, CS3 C00 6 is found when beryllium hydroxide is evaporated with acetic acid. The structure has central O atoms surrounded by 4 beryllium atoms located at the corners of the tetrahedron with 6 acetate groups arranged along the 6 edges of the tetrahedron. Okay, complex compound of magnesium. Complex compound of magnesium. Okay, complex compound of magnesium. Okay, chlorophyll is the most important complex compound of magnesium. Chlorophyll is the most important complex of magnesium. Chlorophyll is the most important complex of magnesium. It is green plant pigment. Green plant pigment. Magnesium is at the center of the flat organic ring system called porphyrin, in which 4 heterocyclic nitrogen atoms are bonded to the magnesium structure of chlorophyll. Has been, you can show also this is the magnesium, this is the nitrogen, and this is the nitrogen. And after this is alkyl group is joined with nitrogen, and this is R2 R3, and this nitrogen which R1 R, and this is alkaline. Okay, and this nitrogen is R6 R7, and this is okay, and this nitrogen is R5 R4, and this is nitrogen. Okay, this is nitrogen, and okay, this is skeleton of chlorophyll molecules. Okay, chlorophyll molecules. Okay, this green plant pigment magnesium is at the center of a flat organic ring system called porphyrin, and complex of calcium, strontium, and barium. Okay, then calcium and other elements only form complexes with strong complexing agents such as acetone, nitrogen atom in each molecule. The structure of EDTA complex has been, you can show, and biological importance of magnesium and calcium. Biological importance. Biological importance importance of magnesium and calcium. Okay, magnesium and calcium. Magnesium and calcium play an important role in biosystem. Magnesium is an important constituent of chlorophyll, which initiates the process of photosynthesis in green plants. In this process, carbon dioxide is converted into sugars. Carbon dioxide is converted into sugars. So CCO2 plus 6H2O. 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 That is chlorophyll. That is chlorophyll. Chlorophyll. That is chlorophyll. Sunlight. Sunlight. Okay. Carbon dioxide is converted to in the presence of chlorophyll in glucose. C6H12O6. This is a glucose plus carbon dioxide CO2. Our life ultimately depends on the chlorophyll and photosynthesis. Magnesium plus 2 ions are concentrated in animal cells. Magnesium plus 2 ions are concentrated more in intracellular than in extracellular fluids in animal bodies. The presence of magnesium plus ions is required for the activation of a phosphate transfer enzyme which participate in the energy releasing biochemical process occurring in animal body. Magnesium plus 2 ions are also required for carbohydrate metabolism. Magnesium plus 2 ions and calcium plus 2 ions are also responsible for the transmission of electrical impulses along the nerve fiber and for the contracting of muscles. Calcium plus 2 ions are necessary for the formation of bones and teeth. It is also essential for clotting of blood. The enamel on teeth is also a double salt of calcium, which is fluoropytite. 3Ca3PO4 whole twice into CaF2. This is the fluoropytite. Okay. It is also essential for maintaining the regular beating of the heart. In addition to this, there are many enzyme reactions that are regulated by alkaline earth metals, cations, calcium plus ions, and magnesium plus 2 ions. Okay. Alkali and aryl derivatives of alkali earth metals. Alkyl and aryl derivatives of alkaline earth metals. Alkyl and aryl derivatives of alkaline earth metals. Organometallic compounds of alkene earth metals. Organometallic compounds are those compounds in which the carbon atoms of organic groups are bonded to metal atoms. Beryllium and magnesium form many compounds with MC bonds, but calcium, strontium, and barium form very few compounds. The dialkyl beryllium compounds can be prepared as follows: 2LIR plus beryllium chloride, BCl2, that is ether. Beryllium, BeR2, beryllium alkyl plus 2LiCl, lithium chloride, and beryllium plus HgR2, that is warm, and BeR2 plus Hg, where R is alkyl group. Okay. Dimethyl beryllium is polymeric. Dimethyl beryllium is polymeric. Okay. BeMe2. Magnesium forms two types of organometallic compounds, RMgX and RMgR. Mg reacts with an alkyl or aryl halides to form organometallic compounds in presence of dry ether, which is called Grignard reagents, RMgX. Grignard reagents. RMgX. This is a Grignard. This is a Grignard reagent. Grignard reagents. Okay, and RX. Rx plus Mg, that is dry ether. In the presence of dry ether, RMgX, Grignard reagent. This is Grignard reagent. Reagent. Okay, Grignard reagents. Where R is alkyl, R aryl group. Aryl group. X is calcium, chromium, and iodine. Okay. RBr plus magnesium, dry ether. That is RMgBr, Grignard reagent. This is Grignard reagents. Okay, Grignard reagents. And CH3Br, okay, plus magnesium and the presence of dry ether. CH3MgBr. C2H5Br plus Mg. And the presence of dry ether, that is C2H5MgBr. C6H5Br plus Mg, that is dry ether, that is C6H5MgBr. Grignard reagent is very useful in organic synthesis. It is used in intermediates for the preparation of a variety of compounds. For example, RMgBr plus H positive ion, that is RH, hydrocarbon. RMgBr plus iodine, that is Ri, alkyl iodide. That is alkyl iodide. Okay. RMgBr plus CO2 and the presence of acid. That is RCOH. That is carboxylic acid. Carboxylic acid. RMgBr plus O2, acid, and the presence of acid, that is ROH, 1 degree alcohol. That is 1 degree alcohol. RMgBr plus RCHO plus H2O, that is R2CHOH, that is 2 degree alcohol. RMgBr plus R2CO and the presence of plus 2O, hydronium ion, R3COH, 3 degree alcohol. Okay, and 2RMgBr plus beryllium chloride. That is BeR2, beryllium alkyl, plus 2MgClBr. Okay, RMgBr plus BCl3, that is BR3. Okay. RMgBr plus SiCl4, that is RSiCl3 into R2SiCl2, R3SiCl, R4Si, R4Si. Alkyl R-oryl chlorosilicate, chlorosilane. Okay, the carbon magnesium bond in RMgX is covalent but highly polar. Okay, RMgX, that is R delta bond, MgX delta bonds, sigma bonds. Okay, sigma bonds. Okay, RMgX, that is R negative plus MgX, sigma bond positive. This is the carbonium nucleophile. This is the carbanion. This is the carbanion. This is the carbanion nucleophile. Okay. Grignard reagents are not stored but are made and used during reaction. X-ray study shows that magnesium is tetrahedrally coordinates by halogen. X, the organic group, and oxygen atoms form ether molecules. That is magnesium X R Et2O. Okay, that is magnesium, bromine, C2H5, and this is C2H5 whole twice O. This is bromine, and this is C2H5 whole twice oxygen. Okay, this is the structure of Grignard compounds. Where Et2O diethyl ether, C2H5O, C2H5. Okay, dialkyl magnesium Mgr2 can be prepared when magnesium is treated with dialkyl mercury, that is Hgr2 plus magnesium, that is Mgr2 plus Hg. Okay, this is a dialkyl can be prepared with a alkali mercury. This is the mercury, and this is the dialkyl magnesium. Other alkaline earth metals also form dialkyl and diaryl compounds. These are prepared using Grignard reagents. BeCl2 plus 2MeMgCl, that is Et2O, that is BeMe2 plus 2 magnesium chloride MgCl2, and beryllium plus Hg Me2, and the warm, that is warm, BeMe2 plus Hg, mercury. Dialkyls are diaryls of magnesium, calcium, strontium, barium can be prepared by similar method. The calcium, strontium, and barium compounds are much more reactive than magnesium compounds. The beryllium alkyl react with beryllium chloride to form beryllium Grignard compounds BeMe2 plus BeCl2, that is 2MeBeCl, where Me equal to methyl group, methyl group and CH3. This is methyl group and CH3, and these are less reactive than magnesium compounds. Okay, these are less. These are less reactive. These are less reactive than magnesium compounds. Okay. This chapter is ended, and next chapter we will be start in next video. The next chapter is started of P block elements. Okay, P block elements part first. Okay, we will be start the P block element part first. Okay, thank you.